Hey guys, welcome back. So till now we have learned introduction to data structures and algorithm. Next we saw what is recursion. Then we also learned algorithm runtime analysis. Then we saw what is array and what is linked list. Hope all these topics are clear. Now with this video, let's start the next topic, that is tree. So let's get started. Now as we have already said that any topic that we learn in data structures and algorithm, we already use all of those concepts in our day-to-day life knowingly or unknowingly. Similarly, when it comes to tree data structure, the rules remains the same. That is, we already use tree data structure in our everyday life. So let's see one example where we use tree in our everyday life. So let's say this is a summertime and we need a cooling device. Now when we go to the showroom, the salesman over there gives us two options. He says that either we can buy an air conditioner or a cooler. Now again, within these two options we have multiple sub options. That is, if we buy an air conditioner, there are two options. We can either go for window AC or split AC. Similarly, if we are buying a cooler, we have two options. Either we can buy a desert cooler or a tower cooler. Now if we go one more step further, we see that in case of a window AC, we have option. That is, we can go for 1.5 ton. But if we go for a split AC, we have two options. We either can go for 1 ton or 1.5 ton. Similarly, if we go for a desert cooler, we have two options. That is 60 liter or 80 liter. Similarly, for tower cooler, we have two options, 45 liter or 60 liter. So we see that the salesman has used such a nice hierarchy to explain which cooling device should we go for. Little does he knows that he is using nothing but a tree data structure. Now in the world of data structure, we call this a decision tree. Now a typical tree data structure is exactly same as the one that we are seeing right now. So let's see that in the next slide. Fine. Now let's see what are the properties or the common observations from the above diagram. So the first property is that the above diagram was used to represent data in a hierarchical form. What that means is, every time we come down to a step, it is more specialized form of its parent. So for example, if we are coming down from air conditioner, we see that window AC is basically a type of air conditioner, but it is a specific type. Similarly, if we go towards right, we see that split AC is again a type of air conditioner, but it is a specific type. So what that means is, every time we go down, we are doing in specialization, or in the other words, we are maintaining a hierarchical form. Now let's see what is the second property. So the second property is that every node has two components, that is data and reference to its subcategory. So let's say if we consider this product as a node, then we see that it has a data. In this case it is an air conditioner, and reference to its subcategory. That is, it also stores the address of its subcategory, which is window AC and split AC. Similarly, if we see cooler, so we have a data over here which is cooler, and it also stores the reference of its left category and right subcategory. Fine. Now let's see what is the third property of the above picture. So the third property is that at top it has a base product and two products under it. So at the top we see that it has a cooling device product. Under that it has two products, air conditioner and cooler. Similarly, if we consider cooler as a top product, then under that we have two products, that is desert cooler and tower cooler. Fine. So these were the three properties of the above picture. Now let's see what are the properties of a tree data structures. And we will be very surprised to know that the tree data structures property is no different than the property of this picture over here. So the first property of a tree data structure is that it is used to represent data in a hierarchical form, which is same as property 1. Now the next property of a tree is that in every node we store two components, that is data and reference, which is very similar to property 2 of the picture, where we were storing data and reference to the subcategory. Now the last property of a tree data structure is that it has a root node and two disjoint binary tree called left subtree and right subtree, which is again very similar to property number 3 of the picture, where we had a base product and two products under each of the category. Fine. So now we have seen what is the property of a tree data structure. Now let's quickly see one sample tree data structure and see that does this property fits in that tree or not. So this is a tree data structures having rooted at V1 and then we have subsequent nodes. Now if we closely see this tree, we see that the data that is represented in this tree is in hierarchical form, like V2 and V3 are child of V1, V4, V5 is a child of V2 and so on. So it is showing the data in hierarchical form. So property 1 is satisfied. We also see that every node has two components in it, that is it is storing the data. In this case it is storing V2 and the reference to its child, which is V4 and V5. Similarly, if we see node V3, so it is storing the data V3 and the reference to its child, which is V6 and V7. So it is satisfying property number 2 as well. Now the third property was it has a root node and two disjoint binary tree. So here we see V1 is a root node because it is the first node in the tree, and then it is referencing to two nodes over here, V2 and V3, which are nothing but left and right subtree. So property number 3 is also satisfied. Fine. So this is all about tree. So what we have learnt is that a tree data structure has basically three properties. That is, it represents a data in hierarchical form. Every node has two components in it, which is data and reference. And finally, we have a root node at the top, and the root node typically references two binary tree, that is left subtree and right subtree. Fine. So I hope we have understood tree on a very high level. Now we will end this video here. In the next video, let's talk about why should we learn a tree data structure. Is not an array or linked list that we have previously learnt good enough? Let's see that in the next video. Thanks for your time. See you in the next video.